We see is most cabinets are looking at about 30 amps worth of power going to a cabinet, and that's about 200 watts per square foot. Most data centers are built anywhere between 50 and 80 watts per square foot. Some of the newer ones were built for 120 watts per square foot. So most data centers cannot support the watts needed for a cabinet under today's high density needs. If you go to blade server cabinets, you're up in the over 800 watts per square foot. What basically happens under this scenario is if this is your current data center, if that data center there can hold 46 cabinets and it's designed for 120 watts per square foot, we can only put 3 servers in a cabinet. So 75% of each cabinet has to be empty. So not a very efficient use of space. Remember, most data centers are in that 6 to 80 watts per square foot. It's even less density. You could probably put only 2 servers in a cabinet. Now, if you were to put some blade servers in replacement of those standard 2U, 4U servers, in this picture here shows you can only put about 7 blade server cabinets in that data center. All those red blocks on there would be server cabinet locations that you could put no equipment in because your room is out of power and out of cooling. And that's what we're all struggling to accommodate, is to put more servers on that floor, which means we need more power and we need more cooling. To be able to do that, we've got to completely redesign the data center. And this is one of the floor plans of what a high-density data center would look like. Is we've taken the floor height from 6 to 12 inches and raised it to 30 inches. So now I'm 30 inches off your concrete floor. In most cases, I run out of ceiling height room in a lot of data centers to stay compliant with NFPA, the sprinkler requirements for distances, or if you're FM200 or FE25. There's not enough headroom in a building to do this higher data center floor. We've also went to hot and cold aisles. Okay? Hot and cold aisles allow us to blow the hot air that's coming out of the back of the cabinets to one center location, and we actually then, oops, the laser doesn't work, so disaster recovery for the laser. The hot air comes up here, goes up above a ceiling now, what we call a plenum ceiling, and the hot air is now combined across the top of the ceiling and fed directly in to the crack unit or the air conditioning unit. In the past, that air would run across the top of all the cabinets and get pulled in, and we'd be very inefficient in our power use. We've switched almost all our data centers to this design now. Over time, we've seen a 20% reduction in energy cost. 20% reduction in energy cost just by going to the plenum ceilings and getting the air out of the data center up into that ceiling area. And there's a lot of other things you can do in that area, and we can talk about that when there's more time. Getting to our green subject is we've been building green into our data center since 1999. And there's one very selfish reason we've been doing that. As a hosting provider, energy is our number 2 cost. And if we can reduce energy, we can be more profitable, and we can also pass those savings along. We've gone and done things such as energy efficient power and cooling designs, energy efficient transformers. What a lot of people don't understand is every transformer you have in your lineup, you're losing anywhere between 3 and 5% of your power. So if you go to one of your step-down transformers and you feel the heat coming out of it, that's the energy being consumed by watts creating heat, but it's stepping down the power. It's actually consuming power there. We put Econo coils on most of our non-chilled water crack units, meaning in the wintertime, we're not running our compressors. We're using the outside cold air to actually run through our crack units to cool them. We've deployed high-efficiency chiller units. High delta cooling techniques can only be done with that previous slide where we're putting that hot air up into the plenum and bringing it through the crack unit at a hotter temperature than normal. We've put energy-efficient white roofs on all our facilities. That makes a significant change in the amount of cooling you have to do to your data center if your data center is located in an area where the roof's directly above it. In the summertime, a typical roof is running at about almost 200 degrees to the touch. With a white roof, it runs 10 degrees above the outside air temperature. So if it's 90 degrees outside, that roof is only 100 degrees and not 200, and that thermal barrier is coming into your data center, making your crack units work harder. Redirect UPS output heat, we send that out into our shipping receiving areas and to our generator buildings, so we don't have to run as much heat out there in the wintertime. Central humidity control, and we've taken all the holes out of the data center floor, so there's no air leakage behind the cabinets. Approximate data center retrofit and build costs less the land. You can expect to pay between $1,000 and $2,500 per square foot now to renovate a data center. And that price keeps going up. The price of copper, lead, steel, aluminum has been skyrocketing since China's been buying everything they can in the world. And our contractors won't even quote us a price anymore. Excuse me, it's at time of purchase that we get quoted our infrastructure costs. The other thing to remember too is when you build a data center, the actual cost to build a data center, and you amortize that over time, is really only 1/3 of the operating cost of a data center. You've got fuel, and we test our generators weekly and monthly, and fuel went from $1 to almost $4 a gallon. So running at 132 gallons an hour per generator, we consume thousands of gallons of fuel a month just testing generators. So there's a lot of costs there that you may not be directly billed for because your facilities people may be taking care of that for you. I just wanted to run a little bit over to some high-speed networks. Why high-speed networks? TechQuest here has been doing a great job in your region on trying to work with aggregating bandwidth for the hospitals and for commercial customers. The Harrisburg region is in a big disadvantage in regard to low-cost, high-speed fiber over, say, the Philadelphia area. We do almost 80 hospitals from Maine to New England, and of those hospitals, we have 40 of them we run production for. All the production's being run out of our facilities. And we're providing those hospitals in Philadelphia and the Lehigh Valley bandwidth as if the data center was in the hospital, because we're running fiber directly from our facilities to the hospital or to the campus. And we're doing it at a cost that is about 20 times lower than what you could buy bandwidth for out here. So there's significant disadvantage you're at, and I know Kelly and his group are working on that. I've got a hospital that creates almost a terabyte of data a day. Terabyte a day. And we're running that over fiber for about $1,000 a month for a gigabit of bandwidth. So that gives you an idea of what the costs are in the east part. And maybe we can do something here. A little bit about our networks, because I think the networks are critical to anything and a lot of the initiatives you've got going on right now. It's taken us almost 10 years to build our networks in the Lehigh Valley and down the Philadelphia region. But we've been able to connect our 3 facilities with fiber to do synchronous replication. We can do real-time replication between our facilities. And we've also been able to build out fiber hubs in the Philadelphia, New York, New Jersey, and in the future the Harrisburg region to get the bandwidth onto our networks to drive the costs down. And one of the things you'll notice in the picture is almost everything's on what we call a ring technology or loop for redundancy. And you really need to look at that if you consider moving some of your strategic applications, especially second site. If you're looking at second site, you need to do real-time replication. We've got clients that fail over to their second site, their network, in 50 milliseconds. So if they lose their core network seamlessly in 50 milliseconds, they're on our network, on their backup systems at our site. And that can be done. And it's not expensive.